Right, in this video, what we're going to do is talk about our final line of defense, which is the specific line of defense. We know that we are talking now about specialized cells, and what they can do is remember and target a specific type of foreign material. We always talk about B cells and T cells. They're our main kinds, and we know we've talked about the white blood cells being neutrophils or macrophages or monocytes, all those kinds of things, but we want to just break them up into a different level of classification this time. Blood cells are made in different parts of the body. Do you know where they are found? Right, T cells are made in the bone marrow, but they mature in the thymus, which is exactly what they are called, T cells. Right, the thymus is up here in your throat. There are lots of functions in the circulating blood. Now, T cells are really confusing. You've got to think about this immune response as being a multicellular, multi-level, very complex situation. So I'm going to give you some really basics about what these cells do, but you have to really watch some videos to think about how big and complex this is and how all these things match up. All right, so there are dendritic cells, and what they do is they are immune cells, and they exist on every surface where it's open to the outside world. So these dendritic cells are like the brain of the immune system, and what they can do is take up the bacteria or any kind of pathogen. What they do is they pull it apart and they display parts of it out on its own cell surface to say, hey, look what I found. And basically it's a bring out your dead situation. So this is what they've seen. When they do that, when they've presented that antigen, helper T cells come along. There are many kinds of T cells. Helper T cells are one kind. They have receptors on their cell surface that can look at that antigen and say, yes, we match this one. What they do is then they get activated, and those activation can lead to many different things. They might reproduce, they might start pumping out chemicals called cytokines, which then have a flow-on effect to many other immune cells. So that's just one element of this. There are also killer T cells, and killer T cells do exactly what they say. They are very specific, and they can come along if there is antigen presented on the outside of that cell that is virus infected or bacterial infected, then they can come along and simply wipe it out. Okay, they know there's something wrong there because that antigen is there. Unfortunately, we have to sacrifice that cell, but for the good of getting rid of that pathogen. They terminate cancer cells as well if they can tell that there is something going wrong with the way that they've been dividing. There's a whole bunch of videos here, and I put a lot of them up on the OneNote as well for you to watch, and I really recommend that you do take the time to watch a few of them because, as I said, this is a really comprehensive immune response, and it is specific, and there are so many parts to it. Okay, our B cells, there are two different types of B cells, and they're called B cells because mostly they're made in the bone marrow, okay, often in the long bones. So we're talking in our limbs, our legs, and our arms. Our femur, which is our main thigh bone, is probably the biggest one. If you ever break your femur, there's a lot of problems because a lot of that bone marrow comes out and it can be fatty and lead to a lot of problems in your circulatory system. So we have plasma cells and we have memory cells, very different roles, but both considered B cells. These ones actually circulate in your blood, or they are waiting in your lymph nodes. Remember, you've got lymph nodes up in your chin, you've got them under your arms, you've got some in your groin and lots of other places around your body. Plasma cells produce antibodies. Now, we've heard the word antigen, antibody now, and we've also heard antibiotics. You have to be really careful with what these are talking about. These are working against foreign bodies, right? That's the goal of these antibodies. They are proteins. They are often Y-shaped, or sometimes they actually have quite a number of different arms, so they can be kind of a star shape or have, like a hand, they have 5 little sections of it. Generally speaking, you'll see these represented as a Y shape. And what they can do is they have receptors on the ends here, and they can grip onto those antigens regardless of what they are, but they are going to be very specific. So if you have antibodies to a number of different diseases in your system, they will all have a specific job and all be circulating in your circulatory system at the same time. This is pretty much the rundown, right? Proteins they are proteins that track down and slow down pathogens. So if a T cell sees a pathogen, says, hey, that's not meant to be here, it can alert a B cell, right? So if we flick really quickly back to, say, this situation, not that far back, we go back to this situation where the helper T cell has identified an antigen presented, that activation and releasing cytokines and multiplying, all those kinds of things might actually do this, the trigger of the B cells to say, hey, this is what's going on. It can then start producing antibodies to attack specifically that pathogen or that antigen that it sees. Once it's done, it can it pumps out all those antibodies to go and find that antigen and stick to it, and it can alert macrophages to come and finish the job. When I say finish the job, it means it can come in, swoop in, and phagocytose that bacteria or whatever it is, so actually engulf it. Again, this is a really good video. It is available to you on your OneNote. I'd recommend you go and watch it as well. Good animations. We have the antibody-producing cells, or plasma cells, but we also have memory cells, and these guys are the ones that give you immunity to something. They remember specific antigens for fighting later. Okay, back when you were about to enter school, you would have got an immunization for, say, chickenpox, so that later down the track, you have antibodies because your body has produced them when it first saw that pathogen. Later on down the track, it goes, hey, I remember that one. I know how to fight this, when you actually do get the disease yourself. So a B cell can find an antigen which matches its receptor. It then can activate helper T cells. So these guys are really helping one another out. The B cell can divide and produce two kinds of cells. So far, this is undifferentiated. It is a B cell, but hasn't decided what it's going to do. It hasn't decided if it's going to make antibodies or it's going to stick around and remember that stuff for later. The plasma cells will make the antibodies. They'll roam around, stick to the antigen, and here's the macrophage that can come and actually engulf it and finish the job off, while the memory cells, they're going, yep, I'm going to remember this one for later on down the track. Your immunity, we've talked a lot about the immune system, but immunity is considered to be the body's ability to resist infection to certain pathogens. People who are immunocompromised have a compromising of that system. It means they cannot activate that defense force as well as they could. You are born with innate immunity. Okay? Everybody is born with those blood cells that can do this job, and all those other defenses, our physical and chemical defenses, as well as our non-specific inflammation defenses, but we can acquire immunity in many other ways. Right? You start off with that innate immunity, but we are aiming to also adapt and get better. We have two ways of doing that. We have a natural way and an artificial way. In our natural way, firstly, passively through something like breast milk. Okay, if you're getting those those antibodies through parental breast milk or maternal breast milk, then that's going to add to your system. Once you stop breastfeeding, obviously you're not going to get any more. Okay, you can also naturally acquire antibodies if you are getting infected yourself. Your body is going to make those antibodies to the antigens using your plasma cells. So that's a normal process. All this is happening, without any intervention here. If we look at the artificial, however, we've got intervention. And this first one is active. We are actively giving you a pathogen. We are actively giving you antigen so your body can practice reacting to it, okay? Can build immunity. Another part of this, is called passive. And this is actually when we hand you some antibodies. We say, okay, you're sick, you've got something, you're not going to be able to make antibodies quickly enough. We're just going to hand them to you. Okay, that might happen in a situation where you aren't immunised. So say you're not immunised for tetanus, you stand on a rusty nail and they go, okay, we've got to deal with this really quickly. They have actually given other organisms, and they might have harvested it from, say, horses. They will give a horse tetanus and they will then wait for their immune system to do the natural active immunity, produce those antibodies, and then we harvest them. And what we can do is then give someone a concentrated dose of those antibodies. That doesn't happen very often because we are doing this active immunization in our community. Vaccinations, they're great. They prepare your immune system for fighting. They are live or inactive. Okay, we don't know what kind of pathogen they are giving you. You can do a lot of research to figure out what kind of antigen they are giving you. But the important part of this is that your body is recognizing that the antigen is there and knows how to do something with it. This is probably an older version of our Australian vaccination schedule. There's a lot going on in here. That doesn't necessarily mean that you're getting, when you're 4 months old, you're getting 6 needles. It might be that they've combined a few. But even here, diphtheria, tetanus, and pertussis, so they call it DIPT, something like that. That's 1 needle. So you are getting immunised against quite a lot. As soon as you come out, Hep B, right? 2 months, 4 months, 6 months. It's important that people follow this schedule for very good reason. Some people say, all right, vaccinations are super bad. We don't want to deal with them. Let's slow down this schedule, or let's not have them at all. And that's when problems arise in the community. Autoimmune disorder is really interesting because if we're talking auto, it means something is happening with our self, and that means our immune system is turning on our cells. And there's so many different versions of an autoimmune disorder. All right, I've got eczema, it does that to me. My immune system is attacking my skin. There is rheumatoid arthritis, so the body is attacking your joints. Body mistakes some part of itself as a pathogen and attacks it. Okay, we've talked about molecular mimicry, where bacteria antigens look like something in our own body and we may let them slide under the radar. But unfortunately, this happens quite often. So that's the joints of someone with rheumatoid arthritis. Very unpleasant. Super unpleasant. I can't remember what this one is. Might be psoriasis. I'll have to have a think. And allergies play a role in here as well. This is what's happening when your immune system is reacting, but it's going way too far over the line, okay? Harmless antigen, peanuts, for example, and your body says, hey, that's not meant to be here, let's get rid of it. And instead of just kind of quietly disposing of it, it's really mounting a massive immune response, and that can become a huge problem.